Okay, so good afternoon and welcome everyone to the fourth online energy efficient building seminar. My name is Hugh Whiriskey. I'm the Technical Director at Partel, and I'm delighted to host the fourth session in the webinar series. Before we start, I'd like to introduce you to the EEBS event. The key theme for this year is Empowering You for nZEB. The EEBS event is part of a collaboration between some of the most knowledgeable experts in the low energy building industry, from practitioners, educators, and communicators. And Partel, in partnership with Core, Daikin, NorDan, and Harmony Timber Solutions, are responding proactively to the recent changes to the building regulations. And during the 4-week session, we'll be providing an integrated approach to sustainable building design and construction, all in accordance with nZEB requirements. The CPD Webinar series will present a range of envelope and building performance solutions that aim to help you meet the nZEB standards for both new build and retrofit projects. You're invited to join us for the rest of the presentations later this week and next week, and all will be recorded afterwards. I'd like to take this opportunity to thank our generous media sponsor and partner, Passive House Plus. Passive House Plus, led by Jeff Colley and his team, are an incredibly valuable information source, completely focused on energy efficient building and healthy, sustainable, ethical approach to design. So on today's seminar, the fourth is presented by John McMenamy. He's the technical manager at NorDan. John will be talking about window solutions, glazing timelines, how to specify timber and aluclad windows, how this integrates with building regulations, and more. John has been working in the industry for 35 years, really broad experience from a carpenter working with timber frame and offsite construction, but since 1999 has worked in the fenestration. In 2004, joining NorDan UK, where he looked after their certification and testing. He has been and is involved with the specification and installation of windows and doors for large housing developments, one-off houses and commercial projects. And I can say personally, from my dealings with John, he's been an extremely knowledgeable, solution-orientated, and I suppose very practical in his approach. So looking forward to the presentation. Before we switch over to John, I just want to say to use the chat box, please, to send the questions during the presentation, and we can answer them all afterwards, or if you want to send by direct message to me. So we'll now switch over to John, who will start to take you through his presentation. Thank you. John, are you getting access there?
I think so. Are you seeing my presentation up there now?
Yeah, it's perfect. Cheers.
Okay, great. Thank you, Hugh. Good afternoon, everybody. I'm going to talk about timber and aluclad timber windows, just perhaps from an nZEB perspective. But just to differentiate first, there is a difference between different types of aluclad construction. So we'll cover that. So who we are. NorDan are sorry, I've got one screen too many here. Excuse me, just bear with me. NorDan are a Norwegian company. They're based in Moi, which is in the southwest of Norway, near Stavanger, directly across from Aberdeen. The company is in the third generation of family ownership and management. It was started in 2026.
John, your mic is getting cut just a little there. I think so, just a little bit hard to hear you at times.
Is that any better, Dana?
Perfect.
Yeah. Yep. Okay, apologies there. Okay, it's in the company is in the third generation of family ownership and management. Been in Ireland since 2003. We have about 50 employees here. That will give you an indication there now, that next slide, where the company, 11 factories, Norway, Sweden, Denmark, Poland, and Lithuania, 2,000 odd employees. that turnover is in Norwegian kroner. I think that's a year or two old. It's approximately 290 million euros of a turnover and AAA rated in terms of financial stability. Okay, what is Aluclad timber? What is composite? There are different window constructions that are described as Aluclad. Perhaps it would be more accurate to describe certain windows as composite. What we're looking at there is a cross-section of a window, which is a composite window. It has a timber frame and an aluminium sash. Other variations on that theme there now would include something very similar, but with a polymer insulator between a timber frame and again the aluminium sash. And then you get rather more exotic composite constructions where we have a PVC core, an aluminium cladding, and an internal cosmetic timber liner. All of those would commonly be described as Aluclad, but more accurately, they would probably be better described as composite. Now, Aluclad timber, these constructions here that we do and some others, it's a timber frame and sash with an aluminium cladding on there that functions purely as a rain screen. It's there for maintenance perspective only, so you don't have to refinish or repaint the window. You'll see it in section there. On the left-hand side is the aluminium clad profile. You take off that aluminium cladding, you have exactly the same profile. So the performance of the window is identical, whether it's timber or aluminium clad, the U value, solar factor, strength, water resistance, all exactly the same. The purpose of the aluminium, as I said previously, is so you don't have to paint the thing very often. Now, the advantage of that is that the timber is, I suppose from an nZEB perspective, talking about operational energy. One of the other factors that should be considered when specifying building materials is the embodied energy. And timber as a material, it's probably in terms of all the window framing materials, PVC, aluminium, steel, or other composites, it's the lowest embodied energy of all of the other materials, significantly less than PVC and aluminium. So if we're talking about sustainable development, that if you go back to the Brundtland Declaration, sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Using timber as a frame material, it's not only carbon neutral, it's carbon negative insofar as the timber is a carbon sink. Now, historically, when we've talked about window performance, the only really factor that people think of is U value. So just have a quick overview of U values. We just started out with single glazed windows, U value of 5.6. The addition of double glazing halves the U value and consequently the heat loss. Put a little bit of argon in there, doesn't make a huge difference. The next big difference is the advent of low E coatings, which again, more or less halve the heat loss again. Now that low E coating, they're either tin or silver oxide combinations. In terms of thickness with the current generation of low E coatings, if you took a pencil and stuck it on top of the Eiffel Tower, that would be the relative thickness of a low E coating on top of a 4mm pane of glass. So they're very thin, but they're the fundamental performance indicator for the thermal photometric properties of the window, the coatings themselves. The next big addition then is triple glazing, again more or less halving the heat loss. Irish building regulations by comparison started out at 3.6 in 1991. Currently, the last revision of Partel brought the backstop U value down to 1.4. Now, again, as an indicator of the development and the advance in technology of Windows, over the last 30 years, the heat loss through Windows has been reduced by a factor of 8. I think if everything had improved to that degree that I don't think we'd be having to worry about nZEB or even passive house standards now. Everything would already be there if everything had improved the same way the window industry has. Now, our standards by comparison, just as we've got a double glazed window U value of 1.2, our standard triple glazed window 0.8. Other window manufacturers would be similar, slightly higher. So that's the level of window that's currently on the market today. Now, nZEB, where does it go? The backstop value, as I mentioned there, was 1.4, but if you build everything to the backstop value, as most of you know, you're not going to meet the overall value. So that in the current updated Part L, there are 4 or 5 worked examples in the annex at the back. All of them seem to take this U, the windows and U values at 0.9 for the U value and solar transmittance of 0.6. Now, I assume that's the glass only rather than the whole window, which is sometimes used in the deep calculation, but I presume it's the glass only. So that's probably what's going to be required. Triple glazing with a U value of 0.9 and that solar transmittance of 0.6. My own feeling that 0.6 may present problems, particularly with overheating. There's certainly evidence at the moment that very airtight and very well insulated buildings do have a problem with overheating. And the SEAI have commissioned some work from, I think, ACOM have done a study for them, but one that is, I think, perhaps more in depth at the moment is one that's on the English Department of the Environment. They have published a paper. It's an annex to the approved documents. It's only a consultant version at the moment, but for anybody who's interested in it, it's on their website. They look at the factors affecting overheating, but also the knock-on effects. So it's not just to do with Part L, it also looks at ventilation. It looks at the implications of having to open windows to reduce that heat gain, the implications for security, and also the noise within the dwelling. So you can say, all right, well, the dwelling overheats, open a window to get the heat out. You may live in an area where that might present difficulties if you're on a busy road or there's a security issue. So it's quite an interesting document to have a read of. But this bit that I've highlighted, mitigating measures that they suggest to take, they're talking about bringing the G value down to 0.4 rather than 0.6. They're also talking about external shutters instead of internal blinds, which are mentioned in the ACOM document. Internal blinds will reduce heat gain, but that heat is already inside the building when it's gone past the glass. So external shutters, something to perhaps consider, but the easiest way and probably the cheapest way to do it is to reduce the G value of the glass. Now that will have other knock-on effects in terms of heat gain in the winter, but I think that's something for designers to consider, the pros and cons of that having too much heat gain. Okay, building regulations that are affected by windows, related to windows. Normally, again, just think of Part L, but Part B, fire safety, emergency egress. Part D, materials and workmanship. Part F, ventilation. That's primarily to do with rapid ventilation rather than trickle ventilation. Obviously, Part L, Part K, stairways and guarding in particular, and Part M, access and use. So you add all those up, the window and the door, multifunctional. Now, this quote comes from an architect who wrote a book for TRADA, the Timber Research and Development Authority in the UK, Wood Windows, Designing for High Performance. Although the window is one of the most critical components in any building, it is often the least well specified. I suppose one has to ask, what are those critical components? What does a window do? All right, it lets in daylight first. So that's the primary thing, let in sufficient daylight. It should also allow visual contact with the surroundings, so people have some half-decent view out. Keep heat in the winter. Keep heat out in the summer. Ensure good weather protection. You don't want wind or rain coming in. Allow controllable ventilation of air into the building. Keep out excessive noise. And last but not least, ensure the safety. Stop the occupants from falling out. So to have the window do all of that can often result in compromises. Sorry, we'll just shut ahead there a few slides. Right. Now, weather, that's a big factor in any window. It has to be designed for the climate in which it's going in. This is a precipitation map of Europe showing rainfall. You'll see that the highest areas of rainfall there are the Alps, the Pyrenees, the Balkans. The west coast of Ireland, Scotland gets a fair amount of rain, but the heaviest rainfall is in southwest Norway. In addition to that heavy rainfall, the Norwegians also benefit from the same Gulf Stream driven wind that we get here. So they get at least as much rainfall as we do, and they get the same rain driving it. So they have very similar weather conditions to southwest Norway that we have here, which makes the design of their windows and what they do to achieve a good weather type window pertinent to what we do here. Now, this next slide will show you the effects of wind-driven rain. This map is a compilation of two data sets, rainfall and average wind speeds. It's provided by Joseph Little Architects, and it's based on the BRE 262 document that's issued by the Building Research Establishment in the UK, showing the effects of wind-driven rain. And it breaks it down there into four categories. And this one here, we've got the highest, the three highest of those four categories. We've got very severe, severe, and moderate. So you can see from that that the vast majority of Ireland is either very severe or severe wind-driven rain. Now that becomes very pertinent when it comes to the detailing and installation of windows and doors. They're pretty much the only perforations in the shell and fabric shell of the building, so we have to try and make sure that they're not only thermally efficient from an energy loss, particularly NZEB perspective, but more importantly, that they're physically robust. You don't want the things leaking or becoming loose under wind-driven rain. So installation detailing. Now, this comes from an NHBC manual in the UK, but it shows the two types of reveal. On the right-hand side, we've got a common reveal in England, and on the left-hand side, we've got the reveal that's more common in Ireland and Scotland. In fact, in the UK, it's known pretty much as a Scottish reveal. It's a Czech reveal, as we call it here. You will see there that the outer leaf of the construction provides protection to the interface between the window and the wall. The detail on the right-hand side, it's just relying on a tape or a gasket, a silicone, whatever. That's the primary protection. Now, that is much weaker than the detail on the left, because wind-driven rain will directly impact on the seal. That seal will also be stressed by UV light, and it will eventually deteriorate. So in Ireland, historically, most windows and doors have been set back behind that Czech reveal. So that is fundamental to good construction and should be carried through to modern construction. So let's look at some of the situations where that comes into play. What we look at here, on the left-hand side, we have a traditional cavity wall construction, the inner leaf, the outer leaf, 100 mil block on the edge. Now, the issue that we would have with that from a window perspective is that 100 mil block on the edge, our fixing that's going into that, even if it's slap bang in the middle, is going to be within 50 millimeters of the edge of the block. It's very difficult to get an engineer to sign off on any fixing into masonry that's closer than 50 millimeters to the edge of the block. What we would like to see is the inner leaf in some way returned so that it is about 150 mil, then there's 75 mil edge clearance there. So the tendency for designers has been to increase that cavity width and then to keep the U values down and keep the inner leaf on the edge rather than on the flat. Just from a window perspective, that presents problems. So it's something to be conscious of when you are designing your walls. Next one then that we see rather a lot of increasing use of now, particularly in one-off housing, is insulated concrete formworks. Various systems have Agremont certification. This is one that has certification from the BBA, although they're based in Naas. What we see here is the ICF construction of the window. Here there is a timber butt or a timber frame built into the ICF construction to close off the openings. So where they're put in there when the formwork goes in, concrete is poured in, they act then as grounds for fixing the windows and doors too. It makes for a very secure fixing for the windows and doors. It's very easy for us to fix in, either direct fix or put a strap into it. Next one we have, this is another system certified by NSAI. The detailing on this jam is perhaps not quite as optimal as what we saw on the earlier system. We've got the revealers closed out by EPS, and in this instance the fixing of the window would somewhat be more difficult because the fixings, I think what is shown there doesn't exactly show how the window is fixed, but if that window has to be fixed and goes back through the EPS, there's going to be a degree of compression there, which isn't great for fixing windows. Ideally, any window supplier would want something that is permanent and is not going to compress there. The flexible sealant shown on the outside appears to be extremely excessive. If you're just going to be relying on mastic like that as your seal, again, it's not best practice from a window installation perspective. Now, in terms of some of the detailing to meet the nZEB requirements, psi values become very important. What may be helpful to some people is the Scottish accredited details. They have standardized details for most common forms of construction that we use here. You're looking at a timber frame there with a brick outer leaf. So they show the full detail with the various elements labeled, and you'll see in the bottom left-hand corner there is a psi value for that construction. So I think there are similar details there for windows in other constructions and door thresholds as well, available on the Scottish Government website. Now, anybody that works as an architect or as a designer or an engineer that has a specific interest in windows and their detailing and specification, this book produced by Trada, I referred to it earlier, it's about €50, but it's a very good, it goes into the history of windows in the British Isles and in Europe. It talks about their detailing and it talks about their suitability in different environments. I think the last paragraph there highlighted in red, there can be a wide range of quality in products that appear similar. Choosing one of them purely because of cost can lead to inferior performance or reduced durability. It can be difficult for specifiers to determine the quality of different windows without, you tend to be pretty much reliant on the claims of manufacturers, unless the certification scheme is a comprehensive one like an Agreement certificate. It is probably advantageous if you inform yourself with guidance like this that is independent and authoritative rather than necessarily relying on manufacturers, which I suppose we all can be prone to slightly over exaggerating our performance and benefits in relation to others. But it's a very good book available from the Trada website for professionals. Now, in that book, they go into the basics of window design, and we'll have a quick look here at the more important ones. What you see there is a typical window profile. The suggestions are that the weather seal is located at the rear of the window, as far away as possible from wind-driven rain, that there are no horizontal surfaces, that there's a pitch of at least 1 in 8 on any notionally horizontal surface. That will ensure that water doesn't sit on it and pool. And then that there's a pressure relief zone there between the sash and the frame. So any wind-driven rain, by the time it gets all the way back, that gap between sash and frame has de-energized the wind. It's taken all the energy out of it by the time it gets back to the seal positioned at the rear of the window. Now, what we have here is an explanation of the drained and ventilated principle for window design. Very similar to rain screen cladding, that water that hits the face of the window or higher up the building and runs down the facade, it's going to come down the face of that window, and ideally it's going to hit that bottom glazing bead and it's going to run off away and not sit on the window. Now, all seals have a finite lifespan, particularly whether they be silicone or EPDM rubber. That bottom seal there will be subject over its lifetime to fairly intense UV light from the sun. So you'll often see weather seals, they'll have gone black or brittle, and they'll start turning up and peeling away. So at some point during its life, that will in all likelihood fail. If water gets in behind it, you'll then see that the rainwater has a passage to get out at the bottom and drain away again. Now, what can happen with the old traditional design of window is that there was no drainage route for the water to get away. So the water runs down the face of the window. Again, at that point, when that seal does fail, whether it be silicone or EPDM rubber, water gets in there. If it's got nowhere to go, it's just going to sit in there and soak up. It will do it will do either of two things, or often both. It will cause that decay in the wood, and the water will attack the seal of the double glazed unit there, break down the seal, and result in internal condensation between the panes of glass. Now, that was the primary reason why the earlier generation of double glazing and timber windows got such a bad reputation. It was done to that design. Water got in, the seal broke down, and the units were fogged up. They were replaced with a new unit, and exactly the same thing happened. Surprisingly, windows with broadly similar design principles are still being made. They're probably suitable in countries where they don't get the same level of horizontal wind that we get. If you imagine a big pane of glass being subject to 50, 60 mile an hour gusts, there's going to be a lot of flexing of that glass. The more flexing there is, the more likely, the quicker that seal will break down. So drained and ventilated systems are particularly appropriate for this country. Now, there are, in addition to that TRADA book I mentioned, the TRADA also publish what they call wood information sheets. For anybody that uses timber a lot in their construction, there's a whole series of design guides for use of timber for best practice use. The three ones that would be particularly relevant to external joinery are this one, WIS 416. It's a 7 or 8 page document that tells you what you need to specify, what type of timber, what you should be looking out for, and very, very useful guide. Yes, I think 7 or 8 euros from the website. The next one there is preservative treatment for timber. Again, it talks about the different types of usage class and what types of timber require preservative treatment. And the last one there, finishes for external timber. A lot of people will often overlook that in a specification, and it's unfortunate. You spend a lot of time on making the window to a good standard, a lot of money putting it in, and then it's not adequately maintained. But there are authoritative guidelines on what to specify in terms of a maintenance regime. Now, probably the most important thing that I would consider when it comes to timber window after the design of the profiles is the preservative treatment of the timber. All of those documents will refer to it in varying degrees of detail. Now, there are two types of preservative treatment, essentially. There's what's called a superficial process, where there's a flow, it's a flow coating or immersion. So the finished timber frame is assembled and it's either dipped in a vat of preservative treatment or it goes through a painting machine. There's a short video here that will show you. Right, now that is a process results in a fairly shallow coating of preservative treatment. It's about 1 to 1.5 millimeters of preservative treatment. Some of that may be even come off when that window then goes to the next station where it's sanded down prior to painting. So if the maintenance regime on that window is fairly poor and paint starts flaking off after a period of time, which many of you would have seen, if it's then not refinished quickly enough, the wood then starts to go grey and decay, and that preservative layer is more or less defunct. The other problem or potential problem with that sort of coating is that if there's any damage to the window during the construction process, It takes a knot from a scaffold pole or something like that. There's a big dent put in it. Again, that protective layer of preservative has already been pierced. But this particular process is popular with some window manufacturers because it's pretty cheap. The window is assembled, it just goes through a spray booth, and it's very quick. Let's say the traditional method of doing that, which many of you may well be probably familiar with, the vacuum impregnation process. Again, I'm just going to show a quick video of how this process works, and I'll talk about the benefits of it afterwards. Right, that video showed structural timber for framing or for decking. When it comes to window manufacturing, all of our timber would be machined and profiled prior to going into the impregnation tank. When it comes out, then immediately goes into a computer-controlled kiln to dry it out. Whole process takes about 8 hours. But the process is thoroughly controlled to ensure the right amount of preservative goes in there and that it's dried at the right speed in order to minimize any movement or deviation in the timber, seeing as it's all being machined. Now, that then becomes important when we look at the next slide. We can see there from the vacuum impregnation that we get approximately 6 millimeters lateral penetration and a minimal 50 millimeters on the end grain. Typically, it comes in about 125 millimeters on the end grain. But this is important because it's that level of impregnation. It achieves an NP3 classification according to BS 8417. The BS 8417, there you see, is Preservation of Wood Code of Practice. It's a standard guideline for the preservative treatment of timber to ensure its suitability for construction and the climate that we have here in the geographic entity that constitutes the British Isles. It's not an EN or European standard. It's just something that is suitable for the weather that we have here and the building processes. So this vacuum impregnation if you want to ensure a 60-year expected service life, and BS 8417 breaks down service life for joinery in 15, 30, and 60-year cycles. The only way to get that 60-year expected service life is to use vacuum impregnation rather than one of the superficial processes. Now, other factors, not necessarily related to nZEB, but it's something I think is important when it comes to window specification. Fortunately, there's nothing in the Irish building regulations that I've seen that relates or refers in any way to the security of the dwelling. You can see here, this is from the Garda website, though, that we've got approximately, 98.5% of burglaries here are either through windows or doors. I guess the other 1.5%, they can't climb down the chimney or something. Not sure exactly, but the next slide here, the Garda do refer to this on their website. There's a crime prevention section, but this is the only official documentation I've seen that relates specifically to windows and doors when it talks about enhanced security. Now, there is an EN standard, 1627, and there's a scheme run by the police in the UK. It's called Secure by Design. Many of you may be familiar with it, but what it involves is enhanced security testing of products for a building. It's not just to do with windows and doors, it's to do with the whole building, and it's not just, it can deal with schools, it can deal with commercial buildings. But what it's designed to do is to make the job of the burglar that much more difficult. And when it comes into effect with houses, if you, for example, put laminate glass in ground floor windows, makes it very difficult for a burglar to get in. You put a simple lock on a front door. A lot of those Euro cylinders, a thief that knows what they're doing can get in less than 10 seconds. They snap the lock, put a screwdriver in, and they're in. These enhanced security methods make it much more difficult. Significantly reduces the amount of burglaries. Doesn't add much to the cost of the dwelling, and it's something I think any designer should consider. An overall summary then of perhaps things to look at when you're looking at the Windows specification: performance, certification, and warranty. Third-party certification, very useful insofar as the certification body, they will be experts at what they're looking at. Often the specifier may have limited knowledge of the particular product. You've got different types of certification. You've got the basic certification, which involves testing of the window or the door. You've then got an enhanced certification, which involves the testing and the factory audit visits to ensure that what has been tested is being produced on a day-to-day basis. And then you'd have the top of the range certification, which is agreement certification, where the certification body will not only do the type testing, the factory audits, they will also do assessment of the product's durability. They'll do testing, corrosion resistance testing on the ironmongery. They will do cyclic testing, open and closing cycles. So they will have a fuller picture and ability to offer an opinion on the durability of the product. So you get that from the likes of NSAI or BBA. Weather performance, what should be minimum criteria? Most windows and doors on the market should be able to meet a water tightness class of 600 pascals, wind load 1200 pascals. That will vary depending what part of the country and how high you're going. Air permeability, that's relevant to nZEB. Pretty much any window or door now should meet the class 4 category for EN 12207. That's effectively zero air leakage at 50 pascals. That's the requirement for passive house standard, and I think it would be, it's not that demanding for a modern window or door. Again, it may be appropriate that the window should have been tested past 24, secure by design. You do see that in specifications, particularly some of the councils are looking at it and specifying it. Unfortunately, there's no oversight to see that it's enforced. You can put it in your specifications. The manufacturers of windows and doors, everybody has it because they have to have it if they want to sell into the UK, and it's used in Northern Ireland, particularly in public sector housing projects. So it is there. If you want to put it in the specification, it will certainly pay for itself in terms of reducing the incidence of burglary. Sustainability certification, Pefc or FSC for timber, that's pretty much mandatory now. There are different levels of certification. The top end of it is chain of custody, which means that everything that leaves the factory that has full chain of custody. So what has gone in has come from certified sustainable forest. Everything that leaves the factory is certified as coming from that timber. Some of the small manufacturers don't have chain of custody. They will rely on just buying a batch of timber that has FSC, Pfc certification and will sell it accordingly. Environmental product declarations. We have those now. If you want that level of information, we have cradle to grave life cost analysis available, showing all the carbon content on not on the full range of products, but on the majority of them. What sort of warranty should you look at? We would suggest we can provide a 20 to 30 year warranty on the frame, 20 years on a timber frame, 30 years on an Aluclad timber frame. That's as a result of the preservative treatment that we use. Components, ironmongery, glass, etc. Again, we offer a 10-year warranty on those. You will see less than that. You will sometimes see more than that, but 10 years shouldn't be a problem. Glazing units have an expected service life of about 30 years and possibly longer. And then just talked about what's there. Now, this is just a quick video showing Windows what's coming and currently available if you are in the Swedish market, but perhaps due here shortly. So just to give you an indication of where the window industry is going. Now, my understanding is that a 3D printed door blade is due to follow at some point during the year, but that window is available for sale in Sweden and Norway, not here yet. And I think I'd sooner let them, let's say, see how they get on for the first 6 months or year before offering it here. Now, that's it. Thank you very much. I think there's going to be a question and an answer to follow, but if anybody has in-depth questions, please feel free to contact me directly at NorDan over the course of the next week or two. So I'm going to hand you back there now to Hugh.
John, thanks so much for that. Really interesting and great to see, I guess, the level of detail, in particular with regard to weather, which is, I guess, a huge concern for everyone, and probably pretty real, I would say, or well-founded. Also interested to see that you promote the rain screen detail. It's kind of something that came up in the previous presentations as a kind of a reliable and well-founded way to deal with, I suppose, wind-driven rain as a really nice additional improvement. Just on a couple of questions. There's a first one is the presentation provided via, and I think that's already been answered, that it'll be provided via YouTube. But in addition, John, could you answer, there's been a question in about PVC windows and changing of shapes and how they react over time to heat, and what you could expect with the timber or aluclad windows in that regard.
Okay, well, my primary knowledge is obviously in timber windows, but I have a general knowledge of PVC windows. There are different, like timber windows, there are different types of PVC windows. Some have internal reinforcement, some don't. PVC will expand and contract much more than timber and even aluminium. So when it gets particularly warm, a PVC window can expand significantly. Therefore, they tend to put reinforcing profiles within the hollow profile of the PVC section. So if you've got enough reinforcement in there, that reduces the tendency to expand and contract. That can then, it can present some issues then with the insulation values of the profile. The better systems have reinforcement profile that is thermally more efficient. The cheaper ones rely on fairly basic profile, and then you get some systems where there doesn't appear to be any reinforcing profile. They put in a foam insulant to further increase the U value of the framing material itself. So without any reinforcement in the PVC profile, you're very much limited on the size of the opening sections and fixed lights you can make before you start running into problems with it expanding too much when it gets warm. Those issues will also tend to apply on the darker profiles. The lighter white color profiles, much less prone to expansion. But the better PVC systems, that won't really happen. The lower quality ones, yes, it will. I suppose the issue then is for the customer in how to identify what's what. But yes, it's a problem. No, it's not a problem with the better end systems.
Great. I guess the next one is one that you touched on a little. It's about overheating. It's becoming a much more question. I see it coming up all the time, and it's about, someone has asked about retrofit and adjusting the G value, and what are the possibilities with that?
We can do that as window suppliers and window manufacturers. We are not experts on the energy balance. We would take direction from the specifier saying what G value or U value is required. We don't have the competence to advise on what's required. We can just say that's the G value of our window. But there is just people, some people may be aware, may not be, that generally the lower the U value you go, the lower the G value you will go as well. It's just anecdotally and also personal experience, we are aware of overheat. I think anybody that's been in a conservatory with a glass roof in summer or even spring will know the problems with overheating. We've seen it on buildings. I think even Passive House Plus have done articles where you've had on buildings there has been localized overheating even within buildings. So it is a problem. You will get external shading on commercial buildings, but don't tend to see too much of it on residential buildings.
Okay, somebody's asked about the embodied energy of your windows in comparison to PVC or others, and I see kind of in the presentation you've noted that you have EPDs available, which is really, really interesting to see. But do you know how that compares with others?
No, I suppose the format of some of these EPDs, they vary. But what I could do, and I'm happy to send on there was some work that NorDan commissioned back in the, I think it would have been 1990s, early 2000s, from academics at Heriot-Watt University, and they looked at the embodied energy of different window framing systems. And so, for example, a timber window could have had, maybe I'm just looking at something here, 600 megajoules, aluminium clad timber 950, then your PVC 2,600 megajoules, so that's substantially more.
Yeah, I think if you kind of shared that, John, we could include it with a more detailed answer for people if they wanted, but that's pretty relevant.
I'm not sure if I can share it here now, but maybe it's something I could possibly, if you're putting this up on the website, I could put links to that, if that would help. I've got some other studies as well that might be of interest for anybody who's looking at the embodied energy or whole life cycle costings of Windows.
Perfect. Yeah, definitely. I'm sure that's relevant, so we'll include that with the information we send out afterwards. Do you supply the required documentary evidence for BEOs that SCAI are happy with?
Yes, we provide a declaration of performance. In addition to that, we have we supply an email directly from SCAI stating that they are happy with our U-value calculations.
Great. A question on a technical one, I guess. Would you say that NorDan has been able to eliminate or nearly eliminate kinetic, surface, capillary differentials and gravity water penetration on their windows?
Just run that one by me again. It's very technical.
Would you say that NorDan have completely eliminated or nearly eliminated kinetic and surface tension, capillary differentials and gravity water penetration on their windows?
Yeah, yes, I think what that is, if water sort of sitting on something, capillary action holding it in place, and then under pressure of wind blown back. So yes, the fact that we have those sloping surfaces, water won't pool there. And then just that decompression zone between sash and frame. I could give you an example. They would, during the factory tour, we take people over there, we take them to the research and development section in the basement, put a window in a wind tunnel, turn the wind and the water on, take it up to approximately 4,000 pascals of pressure. Now, normally, we test is 600. Take it up to 4,000 pascals of pressure, no water gets in. So that's how watertight those windows are. So yeah, I think effectively, yes, we have eliminated that.
Yeah, thoroughly sounds it. So what's your opinion, John, on inward versus outward opening windows? And I'll connect it with another question. That one relates to external shutters, but somebody else is asking the same question, but about EWI. So you can see that it would make sense to have the insulation overlapping the frame, and maybe the internally opening windows would be better.
Yeah, I have internally opening windows in my own house. Unfortunately, don't have the EWI yet. But what it does do, it gives a greater surface area for coverage with any external wall insulation that's going on there. Also, just apart from that particular detail, inward opening windows are actually safer. They're harder to break into because the burglars don't see where the locking and hinging points are, so therefore difficult to attack. And particularly if you're living in any sort of coastal area or anywhere, I suppose anywhere within 5 kilometers of the coast counts as coastal. An inward opening window, all of the ironmongery is back behind the weather seal. So it's protected from the salt in the air. So I would actually personally prefer inward opening windows to outward opening windows.
Have you any advice for sill profiles suitable for NorDan windows?
We have a range of sill profiles that clip into the windows. I personally, in this country, would always like to see a concrete or a precast sill or something rather. Pressed aluminium sills are not ideal. The aluminium, on the fact that they're almost horizontal, very much subjected to intense UV light, so you will get fading of the aluminium. Can be difficult to seal the perimeter edges of them. So if you've got a precast sill, concrete or stone with a heel on it, that upstand, we provide a little sill that lips down over that, and it provides, the window sits on the sill embedding mastic, that the precast sill closes off that gap. So
Got you. So we get asked a lot about how airtight our timber frames are, and is it something that's difficult to show given it can depend on the window? So I guess it's the question of what airtightness do the windows achieve? And I guess it's a fair point that the focus can, or maybe the windows are part of the airtight envelope, and when tested, if there is issues.
We make the class 4 category, which is effectively, it's 0.
Yeah,
okay. On the horizontal axis, that is, I'm comfortable enough with that. Yeah.
Okay. where are Irish windows made in context of embodied carbon? So is there Irish manufacturing of
There are, yeah. They would. I would think different manufacturers would probably. I'd certainly the largest manufacturer here would certainly have similar declarations of energy. I think because again they're selling into the UK market and it is quite often asked for. They're smaller manufacturers. It's unlikely unless they're a systems manufacturer and they're using the system house documentation.
Okay. A question from Stephen. He's wondering, could NorDan streamline the documentation required for BEO assessors? So he's really asking about the letter from SCI. So maybe we can include that with the notes from today, John. That might be helpful for the BEO assessors.
Yeah.
So Stephen, that's your question. We can pick that up. Something from Patrick. Do NorDan fit their own windows, or is there an after service?
Probably fit about 98% of what we supply. There isn't much of a market here for supply only. Our sister company in Aberdeen would have a warehouse where they supply stock size windows. In Norway, 60% of the market there is stock size windows, but in Ireland, the construction industry has gotten out of the habit of using standardized window sizes, and we pay the price for made to measure windows accordingly.
Yeah, understood. Do you have any solutions for bay windows mounted on an uninsulated concrete sill to prevent cold bridging?
If you want to avoid cold bridging, avoid bay windows. That would be the easiest one.
Yeah.
For what you get from them, it's a cold bridging nightmare.
Yeah, they're a tricky detail to get right, but I guess the detail that would be used generally should actually apply to for I suppose 4 bay windows anyway. So if it's thermally broken, that can be addressed. And
I would like to say we often get just that there's a bay pole there, and people want to try and conceal that structural support within the line of the windows. That's very difficult to do. To keep that, if there's nothing above it, if it's a small pitched roof, we can put a timber post in there, and that will take the weight of a very small pitched roof. If you've got some substantial structure above that, where you need steel to take the weight of that structure above, then getting that steel enclosed in any sort of useful insulation, you're probably going to have to bulk it up so it extends beyond the line of the windows. So they effectively become piers rather than a concealed post.
And it is an area we work in with the thermal bridging, with the Almavert, some of the structural thermal bridging components that can wrap around the steel, or even aerogel. There are some solutions, but yeah, I get it's a tricky detail if it's got some structure. Somebody is asking, do you manufacture in Ireland? I think that's in Norway. So there's another question. How do you deal with the level access for compliance for thresholds?
The door by itself, sitting on a flat slab, that will meet the level access requirements. The profile design, we have the letters from the BBA stating that. The rest of it then depends on what's happening outside the door threshold. Ideally, somebody will use one of your Alma T threshold sections and sit the door on that. That then becomes a physically thermally robust level access compliant assembly. But perhaps the only thing, just to be a word of caution then, with an inward opening door, they have to be very careful or know beforehand what height to set that at, so that inward opening door leaf doesn't clash with finished surfaces internally. Yeah.
There is a comment from Rory about the letter, so I think we'll just engage John with some of the BEO assessors and help to find them a good solution for that. There's another question there on the lifespan of the windows and how often do you need to repaint if it isn't with Aluclad?
Lifespan depends on how well something is looked after, how well it's detailed, how it's put in there. But we would assert that these things have the aluminium clad has an expected service life of at least 60 years and at least 40 years for timber. And that's based on experience of observing windows that have been made. NorDan have been making, say, one particular type that inward opening tilt turn windows since the early 1960s, so have a lot of experience of seeing how they operated. Now, in terms of how often they need to be, maintenance should be periodic, at least annual. If you live close to the sea, you want to be looking at it perhaps 2 or 3 times a year, checking for any signs of corrosion. When it comes to paint finishes, the Aluclad, effectively, you don't need to worry about repainting that. We use a particular category of powder on there and pre-treatment process. It's a coastal grade. It's the highest level of powder coating you can get for aluminium. When it comes to timber, again, it very much depends on the location and the elevation. South-facing facades will weather more than north and east-facing facades. But as a rule of thumb, I would expect it would be every 11 or 12 years with timber. So I can give an anecdotal answer to that as well. The head of the R&D department in Norway was talking to him some years ago. He said he replaced the glass in his windows. I misunderstood him. I thought he'd replaced his windows. He said, no, I just replaced the glass. I asked, why did you replace the glass? He said, well, it's first generation double glazing. It has no gas in it, has no low E coating. So consequently, it was fairly cold. How old are the windows? 35 years old. So that was how old the double glazing hadn't failed. It was just he wanted to replace it. So I said, well, are they timber or Aluclad? He said, they're timber. Next, do you mind how often do you repaint them? He said, I repainted them when I took the glass out. That's the 3rd time I've repainted them since I put them in there. So I asked, what condition were the windows in when you took the glass out and repainted them? He said, looking at them, they are good for at least another 35 years, at least another 35 years. He's the head of the R&D department in the factory. So that's an indicator of the quality of windows they were building 35 years ago and his assessment of how suitable they will be for another 35 years. And they're in southwest Norway, where the factory is very close to Stavanger, so they get that same weather that we get here. So they're not in the dry eastern part of Norway, they're in the wet southwest.
You've kind of answered the next question, and it was about the what changes with the glazing and gas and that kind of thing. And it's probably a realistic decision or thing, John, that I guess a question for me is that it's likely that technology will advance in the next 30-40 years, that's more likely to be a reason that you would seek to change glass, isn't it?
I think the next biggest change in glass will be vacuum glazing. That it is there, but that it becomes mainstream. So you can end up with, instead of having a gas-filled cavity, there'll be a vacuum between the glass. So that will again reduce. But again, the manufacturing process, it's only available in relatively small scale units at the moment. It's still very expensive. It's some way off mainstream usage.
And on the U values for vacuum glass, I guess it's something I've always been aware of, that the changes in U values from which you covered at the start, from 5.6 down to 0.8, it's the biggest change. You know, when we talk about U values, there's been nothing else that's that dramatic. But where do you expect the U values to go with the vacuum insulated glazing?
That will go down below 0.5, 0.4, 0.5, depending. But I think that the most work at the moment is going on photochromatic glasses, with the changing the with electrical inputs, that they're light sensitive, that you can turn them on and off in terms of shading or not shading. So that is more likely to hit the consumer market before vacuum glazing.
Okay.
But some way off yet. We don't use any smart glass here. At the moment, it's too troublesome for residential use, and given the cost of it, we haven't. I think we've supplied a couple of pieces of smart glass for bathrooms, but I think it was too expensive to go mainstream just yet.
I think one thing I've got from it overall, John, it's the level of importance of the glazing unit. You know, it's fine for us with membranes and rain screens. We're not actually permanently exposed, but the importance of speccing something that's totally exposed, long term, you know, it's worth giving it the correct time and attention.
Yeah, well, I think you don't want to be replacing a window after 20 or 25 years. It's an extremely disruptive process, both to the external fabric and internally. If you've got to replace a window with EWI around it, that's quite a messy job. Fortunately, we're some way off here from having to do that yet, but
don't have enough EWI yet for that to be a concern. Yeah, but look, hopefully we can get it right when we do install. John, that's pretty much all of the questions, I think. Well, sorry, there is a few more just come in if that's okay on time. So do Nordland provide a service to specify the level of passive ventilation through trickle vents to meet minimum Part F regs? So
no, we're not ventilation. We're not competent in that. We can provide trickle vents in windows, but ideally we don't like to put a trickle vent in the window. We go to great lengths to make a window energy efficient and airtight, and then somebody asks us to go and put a dirty grey hole in it. It's uncontrolled ventilation going through that. We can do it, but we prefer not to. And we would have to be told by the designer how much air they want through that, because we're not competent. It depends on the design air permeability of the building and the type of ventilation system used in there. So yes, we can put and do put trickle vents in windows, but we will have to be told what ventilation is required to be supplied.
I do agree with you. So last question, John, and we'll move on. So how many weather sets have NorDan windows and why?
Weather sets, I'm guessing that means seals, possibly.
Yeah,
it might be seals.
I guess so.
We only use one because that's all we need. I would pose the question why people have 2 or 3 seals on the window. We have one primary seal, we have a smaller one at the front for dust. It provides some thermal benefit. But that book that I referred to earlier in the presentation from Trada Design and Timber Windows Designing for High Performance specifically points out the dangers of having too many seals in our climate. If you've got high wind-driven rain, if you've got a seal, that first seal, if water gets past that, which it often will, the wind will push it past the first seal. It will then get in. It can't get out because there isn't any pressure to force it out. There's just pressure forcing more water in. And then it will then potentially under pressure, get past the second seal as well. So this design principle of putting the one seal at the back of the window from a weather perspective is extremely important. Adding a second seal or third seal for thermal reasons, they're possibly okay in a Central European climate, but the fundamental here is that you want to keep the weather out.
Yeah, got you. Are the individual window components vacuum treated to ensure 50 mil penetration at each end? I guess from the video you put up that they're treated on the ends, but not to that depth.
No, we do all of what the video showed stock lengths of timber for decking or stud walls. What we do we cut all our timber length to all our profiles to length. We do all of the machining. So all of the components of an individual window are put into the vacuum impregnation chamber before the window is assembled. So you've got that penetration of the end grain. Now that 50 millimeters, that's an absolute minimum requirement. Typically it's up to 125 or 150 mil in the actual chamber itself.
Yeah.
So that is all done prior to assembly. Yeah.
Yeah, perfect. John, I think we'll move on and let people probably get back to the day's work. So just before we finish up, I want to kind of let people know, first thank John for the time and the information, really, really informative, and I guess a hell of a lot more information in there than just a window, and lots to consider. On Thursday upcoming, we've got Martin Williams. He's the sales director at Harmony Timber Solutions. So I'm really interested to see how that I suppose for people to get a greater awareness of some of the quality of the offsite manufacturing in Ireland. And next week you will get to hear from myself on ventilation solutions, followed by a final plenary where we'll be inviting all of the speakers back, and it can be a broad kind of discussion as an overall. The last thing is that today's presentation is recorded and will be made available online. Yeah, hopefully we see you again on Thursday and on Tuesday. So with that, we'll finish for today, and thanks to everyone for attending.
Okay, bye-bye.
Cheers. Thanks, John. Cheers.